Alright, what do we have here? Let's try connecting. Alright, all those chunks, it's not a lot of data, but over serial it kind of adds up. That's all basically fonts. So I'm not showing it here, but the Elm application knows about all the font data so that it can simulate it. It can simulate what we see on the actual screen. So yeah, we are debouncing these requests to kind of show things on the ESP32. So yeah, the actual display is kind of lagging behind. And we can, use different fonts. We can play with the color, well, with the amount of orange. And yeah, there's a bunch of stuff, so whatever you can imagine. I do not have drag and drop here yet, so I'll just remove the text, and you can imagine, there's no like opacity or transparency, but by putting stuff in front of each other, you can kind of simulate it, I guess. Yeah, so that's that. And so let me try a more advanced example. In the past, I think this is a still from one of the videos I have on my YouTube channel, where I tried, I think it was the Ratatouille library, which is a Rust library for terminal effects, or at least terminal UIs. And so what is on this screenshot is basically limited to characters. So each of these is, character, and you can set the background color, you can set the foreground color, and that's all it can do. Well, now, and of course this is sent from Linux through, I don't remember what resolution it was, but it goes through HDMI to this sort of cheap HDMI to composite converter box, which it's kind of blurry, it's nothing special. Yeah, so that's basically going through HDMI to some converter and then to the display. But now we have, on the ESP32, we have basically raw NTSC signal, and there are no converters, there is no anything. And I can do, if I copy paste this, I can do this, right? And this is so nice, this is so crisp. And I am not limited by characters anymore. So I can do anything. I can move stuff around. I can move the text by pixels. Right? I can do really anything. And yeah, I think that's pretty nice. So if I do this X line, I can move it, I can do, basically a strike through or whatever. And so what happens behind the scenes is Elm is calculating dirty tiles. So there is like 8x8 tiles all over this kind of screen area. And whenever I diff these trees of nodes, it tells me, okay, well, if you remove this line, then all of these tiles in this horizontal segment will have to be recalculated, right? But I don't have to recalculate anything else. And I think this shows up in my console. So we are sending 42 dirty tiles. And when I was moving the text around or the line around, it only needed to send 8. Sometimes it sent more. So we are sending the coordinates of those dirty tiles that need to be recalculated, and we are also sending this high-level scene, not through JSON, it's through some kind of binary format. Then we are parsing it on the ESP32 with some C code, and we are basically for each of these node types. So you can imagine in Elm I have these nice high level recursive things, and in C I have those as well. It just looks a little bit different, and we are going basically depth first traversal, so that all the Z levels kind of are overriding each other as they go, and we are drawing all of those nodes, but only for a specific tile. And so if we see that the X line, the horizontal line, doesn't touch this tile at all, it will skip this work. And so we are redrawing each tile. For each dirty tile, we are drawing all the nodes, but only if they are actually relevant. So I think this is pretty nice. So yeah, I don't actually know where I will go from here, but maybe I will start adding sound or some kind of animation system or something. But yeah, this is loads of fun. Alright, yeah, I think I'm rambling. I will end it here. See ya.